Today, does the configuration of your case fans have any impact on the temperature of your CPU and GPU? Let's find out. Hey, it's Jason here from Dad Talks Tech, a channel dedicated to PC building, component reviews and overviews, but also tutorials and educational videos like this one. So consider subscribing if you're new here. We all know that the temperature inside of your case can affect both your CPU performance and your GPU performance. So can we affect the temperatures of your GPU and CPU just by reconfiguring your case fan? But before we jump into that, I want to give a quick update on the channel and let you all know what I have working in the background. If you saw the first video I posted that explains the reason I started Dad Talks Tech in the first place, then you know that a big goal of mine is to be able to plan and build custom PCs and then auction off said PCs for charity. Taking you along with me the whole way from planning and building to auctioning and revealing how much we raised and what charity we as a community donated to in order to make a difference in the world. If you missed that video, I'll put a link up in the corner and you can watch it after this one is over. I've finally started to receive some pieces for the first charity build, and I want to thank Fractal Designs for being the first manufacturer to support the community's efforts in that regard. If you'd like to help me not have to be reliant on the donations and sponsorships of manufacturers and find out how you can get exclusive perks, take a look at my Patreon page and consider contributing to the cause. You can find that link with more information in the description below. All right, moving on to the main point of the video today. Does the placement of your case fans affect how cool your CPU and GPU can get? For my test today, I'm going to start out by using the stock fans that come with the Lian Li Lancool 2 case that I am currently using. Since this case comes stocked with 3 fans, I'm going to test several different configurations to see which ones gives us the best temperatures for both the CPU and the GPU. The configurations are as follows. 1, the stock configuration of front intake, top exhaust, and back exhaust. 2, front intake, top intake, and back intake. 3, front exhaust, top exhaust, and back exhaust. 4, 2 front intakes and 1 back exhaust. 5, 2 front intakes and 1 back intake. And number 6, 2 front intakes, 1 top exhaust. Number 7, 3 front intakes. Number 8, 3 front exhaust. 9, 2 top exhausts and 1 back exhaust. 10, 2 top intakes and 1 back intakes. I think that's it. All right, so let's talk a bit about the testing methodology. The system that we are using is an AMD Ryzen 5 3600 CPU with the Wraith Stealth cooler that comes with the 3600 and an Asus TUF Gaming Evo 5700 XT, all in the Lian Li Lancool 2 case that we mentioned before. If you caught my review of this case, you'll remember that I mentioned that one of the reasons that I really like this case is for the options available for both fan and radiator placement. For all tests, since all 3 fans are exactly the same and since I wasn't worried about noise levels, all fans were locked at max RPMs for both the idle portion and the tests that were taken at load. For each configuration, temperatures were taken after sitting idle for 30 minutes. I then ran a 3D Mark time spy to give a load on both the CPU and GPU. And speaking of GPU, the fans were locked at 40% so that we could get consistent rating to help determine that the case fan configuration was the true differentiator between all the tests. Tests were run at a total of 3 times each configuration, and averages of those tests are the results you will see today. And since the temperature of my room fluctuated a bit throughout the testing process, all temperatures stated will be temperatures above ambient. I should also note that the results are only pertinent to this case and in the given ambient temperatures of the room in which it was tested. If you have a different case, your results may vary based on the airflow characteristics of the specific case and the overall ambient temperature of your room. And with that, let's get to it. Looking at the first graph showing the stock fan configurations at idle, we see that the GPU temperatures are all within a degree or 2 of each other, which should be expected since I wasn't actually utilizing the GPU in any way. CPU, however, varies between 31 degrees above ambient and 36 degrees above ambient. I think what I found most surprising was that there was such a variance in temperature, given the fact that the computer was sitting idle and no programs were running in the background. Now looking at the temperatures with a full load, we see about the same variance in CPU temperatures of a 5-degree difference between the lowest and the highest test, with the best temperature configuration being the 2 fans in the front set as intake and 1 fan in the back set as exhaust. But for the GPU, there was an 8-degree difference between lowest and highest, with the configuration of 1 intake fan in the front and 2 exhaust fans, 1 mounted in the rear and 1 mounted in the top of the case. However, the configurations with the 2 lowest temperatures for the GPU were the 2 highest for the CPU. Given the data here, if you are looking for a decent mix of cooling for your GPU and CPU, and given that the stock cooler on the Ryzen 3600 is the best, I would set my case fans in the 2 front intake and 1 back exhaust configuration. And also, just for giggles, I wanted to see the best temperatures that we could get given all of the fan locations that the Lancool tool has to offer. So I grabbed some other fans and fully populated the case's 8 options for fan locations. 3 in the front, 2 in both the top and bottom of the case, and 1 in the rear. These were tested with the same methodology as the tests with the stock fans. However, the configurations were as follows. Number 1, all fans blowing out. Number 2, all fans blowing in. Number 3, airflow from front to back and bottom to top. And number 4, airflow from front to back and top to bottom. Number 5, airflow from back to front and bottom to top again. And airflow from back to front and top to bottom. Here's the chart at idle. You'll notice the configurations that have the airflow from top to bottom tend to have higher temperatures in the GPU, presumably because the heat from the CPU is being blown down onto the GPU. When we put a load on both the GPU and CPU, we have these results. In my book, the clear winner here is the configuration that moves air from front to back and bottom to top. Each of those temperatures is only 1 degree above the lowest temperature of all tests, which makes a lot of sense because moving the air to the top of the case and out only helps with the hot air naturally wanting to move to the top. The one thing we didn't mention in this video is positive versus negative pressure inside of the case. This shouldn't really be a factor in the temperatures, but may be a factor in your decision as how to orient your fans. Positive pressure is when you have more air flowing into the case than is flowing out, whereas negative pressure is where you have more air coming out of the case than you do coming in. So why does this matter, you might ask? Well, you'll probably get a different recommendation depending on who you talk to, but in my opinion, it is best to run your fan configuration in either a positive pressure setup or a balanced setup, balanced being equal amounts in and out. With a positive pressure configuration, air is also being forced out of the small spaces in the case where they may not be fans, places like space between the glass and the case, or your PCIe slot covers are, if they're perforated in some way. This makes it harder for things like dust and debris to make its way into your case. With a negative air configuration, air can be sucked in through those same cracks and crevices and also bring with it dust and pet hair, causing you to have to clean out your system more often than in a positive air pressure situation. Again, this doesn't really have a bearing on temperatures, but it is something you should consider. So again, these results are fairly unique to this particular case and the fans that are in the system. However, this should give you a pretty good idea of what you can look at in your case to see if you need to tweak your configuration to get the best cooling that your case allows. So what are your thoughts? How would you have tested this? Any suggestions for things I should test in the future, or is there anything that I missed in this particular test? Let me know in the comments below. And if you like this video and want to see more like it, give the video a thumbs up and subscribe if you're new here. Also, remember to take a look at my Patreon page to see how you can help me be less reliant on manufacturer generosity and get some exclusive perks in the process. Thanks for hanging out, and I'll see you next time on Dad Talks Tech.